In this section, we'll look at what we would do when we're planning a flight, where we will have the outside air temperature based on the forecast. So this time we're going to look at a TAS calculation using the outside air temperature. We only require two things to do this calculation: an outside air temperature and the Mach number. If we're given the calibrated airspeed and a flight level, we would then use the calibrated airspeed window on the computer to calculate the Mach number like we have done previously. Using the outside air temperature and Mach number, there are two ways that we could calculate the true airspeed. My preferred method is using the formula, which I'm going to call method 3. This will produce a speed about 1 knot more than using the CR computer due to rounding from the formula. This doesn't really matter because our answer needs to be within 2 knots in terms of the accuracy required for the exam. The second method is to use the CR computer, which I will call method 4. Let's look at method 3, which is using the formula. Our example is where an aircraft is cruising at Mach 0.82 and the outside air temperature is negative 50 degrees Celsius. Let's calculate the TAS. Remember, if we have the calibrated airspeed and the flight level, we can calculate the Mach number and then use the same method. The formula we use is that the true airspeed is equal to the square root of the temperature in Kelvin multiplied by this factor of 38.96 etc. times the Mach number. To convert the temperature from degrees Celsius to Kelvin, we simply add 273 to the Celsius temperature. The formula that we're going to use is slightly simpler, where the true airspeed is equal to the square root of 273 plus the outside air temperature, that converts it to Kelvin, multiplied by 39 rather than this complicated figure, multiplied by the Mach number, and then we will subtract 1 to minimize the error of rounding it up to 39. So in our example, 273 plus the negative 50, add those two, then take the square root of it, multiply that by 39, multiply that by the 0.82 Mach number, and then after you've completed that, finally subtract the 1. Our final answer will be 477 knots. So here are 4 exercises for you to try. Have a go at them. Now we can work backwards by rearranging the formula. If we are required to calculate the temperature, we rearrange the formula. For those of you who are mathematically inclined, you will easily be able to do that. For those of you who are not so keen on algebra, here's the formula. Mach number is equal to the true airspeed divided by the total of the square root of 273 plus the temperature multiplied by 39. If we need to calculate the outside air temperature, we simply rearrange the formula, and this is the formula we'd use again. Once again, here are a few exercises for you to try. Method 4 is performing the same type of calculation, but instead of using a formula, we're going to use the CR computer. So once again, the outside air temperature and Mach number are going to be used. Our example, we're cruising at Mach 0.82, the outside air temperature of minus 50. We want to calculate the TAS. This time we're going to use the true airspeed window, which has 2 rows in it as opposed to the true altitude window. On the Jeppesen, same sort of thing. The first thing is to find the outside air temperature on the lower of the 2 windows. So down here, the outside air temperature. Minus 50 is what we have in our example. Rotate the scale until you find this double-headed arrow and line that up with the outside air temperature. Here's a magnified view of the CR computer. Minus 50 lined up with the double-headed arrow. Notice that there are both positive and negative temperatures. Now we're going to use the 2 outer scales on our whiz wheel. We find the Mach number that's in the question, which is Mach 0.82, which is here. If you want to, you can use the cursor, the straight line cursor, and you read off the true airspeed directly above that. And so in this case, we have a true airspeed of 476 knots. Here are some exercises for you to have a try of. Now we can use the CR computer in reverse and we can actually work backwards. So we're still going to use the True Airspeed window. We'll match up the outside air temperature with the double-headed arrow. In this case, we find the true airspeed on the outside and read the Mach number on the inside. Have a go at the 4 exercises. Here are a series of questions for you to try which should pull together a lot of these techniques that we have learnt. Mach numbers, true airspeeds, outside air temperatures, total air temperatures. Have a go and remember to pause in between and I'll give you the solutions for each row one at a time.